Hey, welcome back. This time around I'm making a tool as part of ToolFest 2021 put on by Emma over at Emma's Spareroom machine shop. Now, if you've watched any of my other videos, you've probably gathered that I have a thing for repeatable tooling. My lathe has an Aloris type quick change tool post, and I've got a series of videos about making a quick change tool post for the shaper. So on my mill, I use these Tormach TTS holders, which all have a 3/4 inch shank, and this face here, which registers against the spindle nose. That's how it repeats. And the nice thing about repeatable tooling, especially with a DRO system like Touch DRO, is the tool library. The library is a list of every single tool and its parameters. Like for this example, it would be 3/8 inch end mill, 4 flute, and it also has the Z offset, which is basically how far the tool sticks down into space. Using the tool diameter and the Z offset, it's possible to change tools without having to touch off every single time, which makes things a lot easier and go a lot faster. So the tool I'm going to be making is something between a Haimer 3D taster and a standard edge finder like this. The Haimer, I obviously don't have one. They're like $600 plus. But it's basically an indicator used to find the edges in the top of a workpiece or a fixture, and it actually accounts for the diameter of the ball at the very end of the probe. Whereas, with an edge finder like this, you bring it up to the edge of your part, and you have to account for half the diameter of this. So you find the edge, and then you move over 100 thousandths. The Haimer, you don't have to do that. I'll leave a video down in the description that explains how that works. Haimer themselves actually have a pretty good video on it. So this tool is going to be based off of this. It's a Brown and Sharpe 738 centering indicator. It's used to center work, I'm assuming in a 4-jaw chuck or on a faceplate. This shank would have been mounted into the tool post, and the indicator actually moves. You can bring it up and then into the work, and you would use just to dial in to center in your work. Now, when I took this indicator apart to clean it, I saw how it actually works. Now, the levers and pivots and everything in here, they're not the important part for this. The important bits, and I actually have another one of these indicators, but the important bits are these two parts right here. This is obviously the tip of the indicator, and this piece, this plunger, sits inside here. And the way that these act on one another, in addition to the plunger moving, or the indicator tip moving the plunger in a linear fashion, I noticed that if you tilt the tip, it still pushes the plunger in and out. So now, because it's moving at an angle, the indication you're going to have here isn't a direct relationship like it is if you just push it inwards. If you move it to the side, it's not, that's not 1/1000th, it's some fraction thereof, but that actually doesn't matter. My intended purpose is something else entirely. What I'm going to do is I'm going to make something to hold this indicator, minus the shank, vertically in the spindle of my mill. And I'm not going to make any plans for this one. I'm just kind of making it up as I go along. I've got an idea of what I want to do. And so I know that I'll have to make a way to center the indicator, make it concentric with the rotation of the spindle. And I'll also need a way to lock that firmly in place. And also it'll need you know, 3/4 inch spindle or a 3/4 inch shank to go in the spindle and some kind of face to register against the spindle nose. All that being said, let's go.
Almost a thou under. It'll be fine. Over at the mill now. This piece just needs a few holes in it now. 3 holes on this face and then 3 around the periphery. And so I've got it in an ER32 hexi block. And we'll go ahead and use the circle function on the DRO. So our radius is, let's see, we'll do the outside diameter minus 1 wall thickness, because this is asking for a radius. That's 0.246. And we divide all that by 2. We want 3 holes. I don't have to mess with the angles. Alright, last thing is to embiggen this hole. It needs to be 1 1/8 inch. And then that should be it, and we're ready for assembly. Alright, so I put this together off camera and putzed around with it for a while, and I found some issues. Firstly, when I made it adjustable for concentricity, I didn't take enough care to make sure that that this face was perpendicular to the axis of the indicator itself, and that gave me all kinds of headache trying to dial this thing in. So what I ended up doing, I
didn't record it. Like, I don't want to record at work. Not because they won't let me, just because I've got coworkers that probably wouldn't leave me alone. But anyway, I clamped the nose of the indicator in a 5C collet in the spindle of the lathe we have at work. And I very carefully just turned this face down to make it perpendicular. So after that, that solved that problem. The other really big issue was the fact that I only put 3 adjustment screws in the shank. And while, yes, it probably can be adjusted that way, boy, was it a pain in the ass. So as you can see, I re-drilled and put 4 set screws in for adjusting this, and it made it significantly easier to dial in. So with those issues solved, I'm gonna go ahead and throw this back together and put it in the mill, and then I'll show how I dial it in. Over at the mill now, I've got the tool put up in the collet and the spindle, and I've got the mill out of gear so I can spin it easy, and you can see the little tip of that thing is just orbiting. So what I'm going to do is dial it in as best I can by eyeball, and once I've done that, I will actually put it in contact with the 1, 2, 3 block and try and get the indicator to read the same thing all the way around. So, all right, time to get to it. All right, I think you get the idea. Basically all I'm doing, just find the high spot, move the indicator away from it. So I'm gonna finish messing around with this and I'll bring you back. So it took a little while, but I got this dialed in pretty well. Within half a thou, a couple tenths. I never had intentions of this thing being super accurate. If I really needed that, I would just use my regular edge finder. This is something I can use that's much faster than that. But anyway, so now that the tool, which I've dubbed the 3D smeller, because why not? Anyway, now that it's dialed in, it's time to calibrate it. Like I said, this tool doesn't account for the diameter of the ball on the probe end like the Haimer does. It's more similar to a regular edge finder that way. So when I'm probing X and Y, when the indicator reads 0, the center of rotation is still a certain distance away from the corner I'm probing. So I need to calibrate it to find out what that distance is.
So I'm going to use my edge finder to indicate the corner of my vise. I decided to just use the corner of the vise instead of the 1, 2, 3 block. It's a better known surface. So I'll probe this corner and I'll move in the 100,000ths for the edge finder, and I'll zero the DRO out, and I'll swap in the 3D smeller and probe the edges, probe this corner again, and that should tell me what my offset is. So go ahead and do that. Okay. All right. We swap tools. A little tap to take out the hysteresis. So it looks like 110, and it should be the same in the X direction. $110. I like that. And it's a nice round number, which is easy to remember. So now, when I probe anything, I just have to remember to add or subtract 110 thousandths from each direction, and I'll be over the corner of my part, which makes life a lot easier. To me, this is a lot easier than using the edge finder. Maybe a little bit less precise, but I'm okay with that. So now, as far as the Z offset, the tool library in TouchDRO assumes that you're already at your origin before you select a tool. So since I'm using 3D Smeller as my origin, or to set my origin, all the tools in the library need to be calibrated relative to it. So I'm gonna go ahead, I'll keep using the vise. I'll get myself to a nice big flat area here. Make sure that's clean. And I'm going to use this piece of card, hold it in the other hand. I'll zero on that. Okay, that's my Z0. Then for poops and giggles, I'm going to throw in an end mill. Take this out.
Okay, right there. So our offset is negative 473 thousandths. So let's actually try that. Add a tool, end mill, 0.375, it's a 4 flute, and our offset is negative 0.473. Okay. Alright, so now that we've used the smeller to set our workspace origin, I guess I'll give you a quick demonstration as to how that works with the tool library and all the different offsets. So I've added a couple extra tools, another end mill and my spot drill, into the library. So bring that up, take it out, and we'll swap in first end mill. And the heat came on. So we'll call it that one. So if I bring this down to touch this piece of paper, that red number should be 0. Yep, and we got good drag. So now we should be able to do the same with the next. You know, say we took a cut with that 3/8 end mill, and now we want to swap out to 1/4 inch end mill. It should be the same thing. I should be able to select that tool, bring this down, and it should be 0 as soon as it touches. And it is. And then one more. Yeah. Now I want to spot drill a hole. So we pick that. This one I'm going to engage the fine feet for. I don't want to jab a hole in my vise. Alright, and there we go. So all I have to do is enter in every tool I have in a holder currently, and I'll be able to just seamlessly switch one to the other, and not have to touch off each time with each tool. So I guess that's it for this one. Thanks for coming along on this, and I hope you enjoyed the new tool, hope you enjoyed the video, and see you on the next one.